next we will look into the PIC microcontroller series. So, this is one of the very simplest microcontrollers that we have, and it ranges over a series of such processors. So, we call it a family of this PIC microcontroller. So, you can have very simple processor microcontroller with PIC, or you can have more advanced versions. Okay. So, when we look into this PIC, so the structure is consisting of these components. There is a microcontroller unit or MCU there. So, and the microcontroller unit, it consists of the microprocessor unit, which will be doing the processing part. It follows the Harvard architecture. So, program memory and data memory, they are separate. So, we have got program memory for instructions and data memory for data access. Then we have got I/O ports, and it will also support devices such as timers. So, 18F family of microcontrollers. So, they will have all these things. So, pictorially we can see it like this. So, as if we have got the microprocessor unit or MPU, and there are address and data buses. So, they are, so this program memory, data memory, I/O port and support devices, they are all hanging from the bus. Okay. So, this is a program, and the address and data buses will be there, from which from the MPU they are connected. Going into more detail, so this MPU, you can divide it into two major portions. One part is the ALU part, where it will be doing the arithmetic logic operation, and the other part is the register part. So, where it will be doing the register operation. So, this PIC18F family, so it has got 21 bit address bus, that is 2 MB of memory, program memory, and 16 bit instruction or data bus. So, this is so you have got 2 mega locations, and each location is 16 bit wide. And for the data memory part, so we have got 12 bit address bus and 8 bit of data bus. Okay. So, 12 bit address bus, so you have got 4 kilobyte of data memory and 8 bit data bus. So, every data location is 8 bit. So, this program bus and data bus, so they are separate. The address bus for the program memory and address bus for data memory, they are separate. And we have got the registers, like we have got the bank select register. So, you can select the alternate register bank. You can have file select register. So, there are some special function registers. So, they can be selected by that. And you see, just like in 8051, we had the situation like the registers are also part of memory. So, here also the same thing. So, registers, they form part of the memory. So, we do not have to there is no other CPU register as such. So, they are all part of the program memory. And then there is a bank select register and there is a file select registers. So, bank select register is a single register that will tell which register bank we are going to use, and file select registers. So, they will select, they will act as pointers for the selection of register from the memory. Then we have got the program counter, that will be there. On the ALU side, we have got one W register or working register. So, this is nothing but the accumulator. So, like other processors, so we have seen the accumulator. So, this is that A register sort of thing, where it will be doing that accumulation job. All the operations will be with respect to this W register. Then there is one status register. So, that is that the status register of other processors also similar to that, and one instruction decoder. So, so as you can understand now what is going to happen, like the instructions are first coming to this instruction decoder. So, instruction decoder will control all other modules that are there, and then we have got this memory select register. So, they will select the register from where the data has to be brought, and they will be do some operation with W register as the source, as one of the source and also the destination, and then from the W register you can move the values to other registers and so on. So, we will see some examples later. And we have got other pins like VSS and VDD. So, they are power, the V, actually there is a mistake here. This VDD is the power line and VSS is the ground line. Okay. This will be just the reverse. So, these two are just the reverse, VSS and VDD. Then there is a reset pin by which you can reset the processor, and there is one interrupt, interrupts are there by which you can have a number of interrupts. Then we have got two more controls, this read and write. So, they will be controlling the read write operation for the read and write signals for the memory that will be provided by that. Now, so if you look into this microprocessor unit, it has got this arithmetic logic unit, registers and control unit. So, arithmetic logic unit, so it has got the arithmetic logic unit will have the instruction decoder. So, all instructions are 16-bit instructions. So, you will have this the instruction decoder, we will have a 16-bit instruction register there, and this status register. So, it stores the status flag. So, there are 5-bit status register is there, and W register is called working register, which is actually the 8-bit accumulator that we have. Okay. So, this is similar to that accumulator register of 8051 or 8085. So, it is similar to that. Next, we have this registers. Microprocessor unit will have some registers, like one important register is the program counter, and since the address bus is 21-bit, so program counter is also 21-bit. Then there is a bank select register, which is a 4-bit register. It is used in direct addressing the data memory. So, you can select the data memory content, you can load from the data memory into this register, the working register, or you can do some operation with the data register with this working register and this data memory registers. So, that way the bank selection is done by the 4-bit register called BSR or bank select register. And there is a file select registers. So, these are 12-bit registers used as memory pointers for indirect addressing the data memory. So, these are 12-bit registers and they will be used as pointers to the data memory. Okay. So, they are useful for getting that pointers. So, you can in an indirect addressing mode. So, if you are trying to get some operand of some instruction, so they will be using these file select registers. Then there is control unit. So, control unit will provide timing and control signals, and the read write operations will be done through this control unit. Address bus. So, we have got two address buses, one is for the program memory, another is for the data memory. For program memory, we have got 21-bit address bus. So, addressing capacity will be 2 megabyte, and in case of 2 mega, in fact, this is each location is 16-bit. So, this will be 2 mega into 2 mega word, where each word is 2 byte long. And then we have got this data memory, which is 12-bit address bus. So, this will be 4 kilobyte because the data bus for data memory is 8-bit. So, this memory is 4 kilobyte memory. Data bus. So, 16-bit instruction or data bus for program memory. So, when you are accessing program memory, so program memory may be accessed for two different purposes. One purpose is to get the instruction, and another purpose is so the constants that we have. So, you can load some constant value from program memory into the processor for doing the operation. So, basically the immediate operand. So, when you have got the immediate operand, so they are also stored in the as part of instruction. So, that way, so you can say it is a 16-bit instruction or data bus connecting to the program memory. So, if an instruction uses that constant data, so it will use the 16-bit constant, or it can if it is storing the values of variables in program in the data memory, then it can use the 8-bit data bus, and those variables are going to be 8-bit wide. And we have got the control signals read and write for the read write operation. So, 18F family, there are many variants. So, there is 452 or 4520. So, this is a slightly improved version, where the program memory size is 32 kilo, and then it is the address range is all 0 to 7FFF, and then the data memory size is increased. So, it is going to be 4 kilobyte, address range is 0000 to FFFX, and there is another data EEPROM. So, that is not part of data memory space, and this is accessed by special function registers, that SFRs. We said that there are bank select registers and file select registers. So, file select registers will be using these special function registers for that purpose. So, this is the structure. So, program memory will be having a 21-bit address bus. Out of that, this part will be useful. So, 32K will only since this has got only 32K. So, this part of the memory is unused. So, from 8000 to 1FFFF, this part. So, this part is unused. So, it has got only 32K program memory. On the other hand, the data memory, so it has got 12 bit address bus, and that data memory is 4 kilobyte, and then it has got data registers and the file registers. So, both are there. So, data memory is divided into banks, as I was telling, there is a bank select register. So, bank select register is a 4 bit register. So, it can contain the bank number 0 to F. So, we have got this 0 to F bank selects, okay. And then each of these banks, it will have some general purpose registers and some special function registers. So, these general purpose registers are 00 to 7F, okay. So, many general purpose registers can be there. So, that is 128, there are 128 general purpose registers in this location, and there is another 128 special function registers. So, each block of 256 data RAM locations, data memory locations, it is divided into registers, out of which 128 are the general purpose and 120 are the special function registers. And this you can select this you can select the proper bank by choosing these BSR bits, okay, setting these BSR bits properly. So, you can tell bank 0 to bank F, okay. So, all the 16 banks can be selected. IO ports. So, there are a number of IO ports. So, port A through port E. So, A, B, C, D, E, there are 5 such IO ports, and most of these IO pins are multiplexed. So, they are multifunctional, just like 8051 ports, they are multifunctional. So, here also the pins are going to be multifunctional. Generally, they have 8 input output pins, individual ports they have got 8 input output pins, and these addresses are already assigned to these ports. So, the addresses are fixed, port A to port E, their addresses are fixed, and each port is identified by its special function register. Just like 8051, you have seen that in the memory. So, we have got locations corresponding to the ports P0, P1, P2, P3. So, here also for each of these ports A through E, so there are corresponding memory locations. So, which we will call special function registers, okay. So, just like you can have this move instruction in 8051, by which you can control the data movement to individual ports, and they are actually mapped onto some memory locations. So, here also the same thing. So, they are mapped onto memory locations and then data RAM locations, and then it is each port is identified by some special function register. So, this is the idea. So, we have got this port A, port B, port C, port D, port E, like that, and then this from the processor we have got for the data memory 12 bit address bus and 8 bit data bus. So, this they are connected to 12 bit address. So, that will select some port A, and this 12 bit address it will also select port B. There will be naturally these addresses are fixed, okay. So, if you put a particular address, the port A will get selected or port B will get selected, and you see that these are the alternates that we have, okay. So, here it is not very clear like what do they mean. So, basically like these lines. So, these are actually these port lines RA0 through RA6. So, these are the port lines. So, it is here this is 7 lines are shown, and it has got some alternate function, analog 0, analog 1, analog 2, analog 3. So, these are also used for so you can connect some ADC through this, and whenever you are if you are doing some ADC, analog to digital conversion, then these analog channels can be connected there. So, there are 4 analog channels that can be connected for analog to digital conversion, and this VREF plus VREF minus. So, this is used for the ADC, and then this is there is some other pins like this is for timer clock, and I think something like that. So, then there is a program these are some other control bits. So, you can find out their meaning from the manual, but they are. So, what I want to show is that all these pins, they are multiplex. So, they are not absolutely dedicated for individual ports. Then this INT0, INT1, INT2. So, these are for interrupts. So, that way, just like 8051. So, we have got the pins multiplexed, the port pins multiplexed. So, here also the same thing, we have got these port pins multiplexed. So, if you talk about the data transfer, so there can be parallel data transfer or serial data transfer. So, both these data transfer techniques, so you can divide it into 2 categories. One category is the transfer is initiated by the microprocessor unit, or the transfer is initiated by the external device. So, either of them can be utilized. So, when it is microprocessor initiated, it may be unconditional. So, unconditional means the processor will just put the data onto the data bus for the port for the device, and it is assumed that the device will accept it. So, there is no other control over this whole transfer process, or there can be polling. So, this processor will poll the device to see whether the device is ready to send or receive data. So, if it is ready, then only the transfer will take place. So, that is the polling mode of transfer, or there can be handshake. So, when the processor is ready to send some data. So, it will put the data onto the data bus, and it will put some valid signal. So, between two modules, so if we are looking into the handshake mode of data transfer, so it is like this. So, if this is a device 1 and this is a device 2, then there is this is the data line that is connected, and so there are some more control, at least two controls are necessary. One is called valid, the data valid, and the other is called the acknowledgement. And the transfer takes place like this, that the initially D1 it will put that data onto the data bus. So, this is the data. Okay, it is better shown in this fashion. So, this data is normally shown, the valid data is normally shown like this, that suppose at this point, from this point onwards the data is valid, data has been put onto the data bus. So, this is the data line, here I have got the data. Then after putting the data, this it will put the valid signal. So, valid signal is activated. So, this data will be there as long as the valid signal is there. After some time, this valid signal is taken off. Okay. And then when on this, while it is falling down, so at that time, so this is the valid signal, the data is received by the receiver. So, this data will be received by the receiver. So, data will be received by the receiver in the receiving device like this. So, this is happened by this. So, this falling edge. So, the value will be it will be triggering this data received. So, this is the data at the receiver end. So, the value is data is received here, and after the data has been received. So, it will be it will be going into, it will be putting that acknowledgement signal. So, this acknowledgement signal is put somewhere here. Okay. So, this acknowledgement signal is given. So, this is basically when the data has been read. So, it will be giving this acknowledgement signal, and upon getting this acknowledgement signal, so this data is taken off the from the bus. Okay. So, this acknowledgement signal, when it is given, this may be triggering the removal of data from the data line. So, that way there will be a proper handshake between the two devices for the data transfer. So, we can have this type of handshaking mode of data transfer. So, that is more complex, and if it is activated by the external device, then this is an interrupt. So, when the device is ready to do the transfer, so it will give an interrupt to the MPU, and then this the MPU will start the data transfer process. So, there are a number of devices that are supported by this processor, like this timer. So, it will capture, compare, and this pulse width modulation. So, this will be, all this can be done by these timers. Then there are serial communications, so that are done by this master synchronous serial port MSSP, and we also have one user. So, this synchronous serial port. So, this is for synchronous communication, and this user, this is a universal synchronous asynchronous receiver transmitter. So, that is for normally it is for this asynchronous transmission. Then we can have AD converters, we can have parallel slave ports or PSPs. So, or we can have this data EEPROM. So, these are the various types of devices that you have with the PIC microcontroller. So, you can, if your device supports any of these modes, or if you need all these things, so you can connect to the device. Like if you have to have some analog signal, so you can connect to this AD channel, and AD converter is there, so which will be taking care of that. So, this is the thing that I was talking about, that this microprocessor unit. So, it has got this IO ports and that data memory is there, and the data memory part. So, it will support this support devices. So, we have got this timer 0, timer 1, timer 2, timer 3. So, there are 4 timers. There is one AD converter, and it is a multi channel AD converter. As we have seen, there are 4 channels by which this AD converter can be connected. Then we have got this other device like CCP1, 2, then the serial port, user, parallel slave port, data EEPROM. So, all these can be connected. So, they are these devices are supported. So, if you want these devices, you can use them. Special features. So, it has got a sleep mode. So, in which the processor will be you can make the processor to go into sleep mode. So, it will the power consumption will be low. Then there is a watchdog timer mode. So, it will be doing some so watchdog timer is it is for if some deadline miss is going to occur. So, you can detect that situation. So, it is like this, that we have got suppose we have got some interrupt, and that if that interrupt occurs, so this interrupt service routine has to be executed. Now, if this interrupt service routine is not complete within some predefined time, for example, for some critical operation, maybe we say that this interrupt service routine should be over within 2 seconds. Now, if that interrupt service routine is not over by within 2 seconds, then it may be taken as a failure for the system, and some higher level activity has to be triggered. For example, if there is a smoke detector, so that detects some fire, and then these fire extinguishers are not activated within a very small amount of time. So, we need to take some higher level action. Maybe we have to inform this fire brigade about this emergency condition and all that. So, that way so there will be some fixed time unit by which this ISR should be over. So, to do that, so what we do at the beginning of the ISR, so apart from writing this ISR code, so we also start a timer. So, we also start a timer, and then either this ISR ends. So, at the end of the ISR, we disable the timer. So, we disable the timer at the end. So, if the ISR is over within 2 seconds, then this timer will get disabled. So, it will not be going to affect the system operation, or if this ISR is not over within 2 seconds, then this timer will overflow. Okay, so, it will time out, and it will generate another interrupt, and that will be a higher level interrupt. So, this way we can have this watchdog timer. So, these type of timers, they are one time timers, and they are called watchdog timers. Then we have got code protection. So, you can protect the code for access. So, there is we can have some address range and protection around that. Then in circuit serial programming, so that is possible. So, we can have so while the circuit is in operation, so you can serially transfer the some programs to the microcontroller, and there is in circuit debugger. So, this will be doing the debug job. So, this will be doing the debug job, and the debugger will be useful for finding problems with the system. Next, so this is that programming model. So, as a user of the system, so you can find out that okay, we have got this MPU that has got this ALU and registers. So, ALU has got instruction register, then this table latch, then this we have the status flag, 5-bit status flag, then the working register, and there is a product register which is for multiplication results, and we have got this registers, program counter, then this table pointer. So, they will be pointing to these various locations for indirect access, then this bit select register, then this file select registers. There are 3 registers, FSR 1, 2 and 3, they can be used for selecting that. So, if you have got this BSR is 0, so it will be selecting this bank 0, BSR 1 will select bank 1, like that, and again this bank 0. So, it is divided into GPRs and SFRs. So, general function registers and IO special function registers. So, plus there are IO supports and other support devices that are there. Okay. So, this is a list of different PIC controllers that we have. So, their capacities and things. So, if you look into these instructions, so there are 77 assembly language instructions. So, the previous versions it had 33 or 35 instructions, but this new version it has got more number of instructions. That way this PIC has become more powerful. Okay. So, compared to other processors, the number of instructions are much less, but you will see that this is quite powerful for doing the microcontroller applications.